This is an example of a Bernoulli's equation question. Figure question 3b shows water is flowing upward at a rate of 0.12 meter cube per second. So Q is equal to 0.12 meter cube per second through a 30 centimeter pipe. So this is diameter equals to 0.3 meter. The pipe diameter is then reduced to 15 centimeter through a reducer. So this diameter is for 0.1, diameter at 0.2 is 0.15 meter. The pressure change across the reducer is measured by a mercury with a SG of 13.6. Determine the deflection H of the differential mercury manometer. So the question over here involves a question of Venturi meter. So this part of the study is Venturi. This part of the study is manometer. So what we need to do over here is to combine the Venturi study and the manometer study. So Venturi will involve Bernoulli equation. Okay, in order for us to calculate this question, the first thing that we need to do is we need to make sure that we have all the information ready over here, which is Q is given here, D1 is 0.3 meter, D2 is 0.15, and we have the density over here. Okay, the first thing to do is to find out what is V1 and V2. To find out V1 and V2, we use the continuity equation, which is Q equals to A times V. So V1 is equal to volume flow rate divided by area of 1, which is, for this question, 0.12 divided by pi. Diameter for 1 is 0.3 square divided by 4. So the answer should be 1.697 or 1.7 meter per second. To find out V2, we use the same way, Q divided by A2, which is equal to 0.12 divided by pi 0.15 square divided by 4. So this will equal 6.79. Okay, so we have V1 and V2 ready. So this is V1 and this is V2. We will continue our calculation by doing a Bernoulli equation study, which is P1 over rho G plus Z1 plus V1 square over 2G is equal to P2 over rho times G plus Z2 plus V2 square over 2G. Okay, so pressure 1, pressure 2 here. So what we put over here is, since we know this is a study between Venturi and manometer, okay, what will be the connection between Venturi and manometer is P1 minus P2, or we call this as delta P. It can be P1 minus P2, it can also be P2 minus P1. So that will be the connection between the Venturi study and manometer. So what we need to do is we need to get the P1 minus P2 from this Bernoulli equation. Okay, so the first thing to do here is we rearrange the equation. So we get P1 minus P2 is equal to Z2 minus Z1, and then we have plus V2 square, velocity 2 square, minus velocity 1 square, divided by 2 times the gravitational acceleration. Okay, and this rho G over here will go to the other side. Okay, So now this is the first equation that we get in terms of Bernoulli equation. Now we will do a calculation for manometer. So for manometer, we do point 2 as the endpoint. So we do P2 equals to P1 here. Okay, and then since this is water, it is and the level here is below, so we add rho water G, and the distance is x plus h. And then we have mercury here, so this mercury will be higher level than the water, so minus rho mercury G H, and then we have water again up until point 2, so from this point to point 2 will be x plus the distance here, z2 minus z1, or we can do a notation here, 1 until 2, we put it as a, for example. Sorry, a. So we will try and do this. We minus water and then G, and then this will be x plus a. Okay, so we get this full equation here. So if we rearrange the equation again to get P1 minus P2 the same as this one, we will get P1 minus P2 is equal to negative rho Wg x plus h plus rho mercury GH minus rho of water, plus rho of water Gx plus A. Okay, now here we have rho water G and rho water times G, so these two represents the same thing, but the height over here is different. But here we have the same x, this is positive x, this is negative x, so we can cancel this out. Okay, rearranging back, so we have rho water G, so this is negative h, and then we have plus A, so plus A and plus rho Hg GH. Okay, and then next we will get P1 minus P2 to be equal to, we do some other factorization here, so we have G, okay, or we open up this equation, so rho water G H plus rho water G A plus rho Hg GH. Okay, so this GH is the same here, here and here, so we will do GH minus rho W plus rho mercury plus rho WGA. Okay, so this will be for P1 minus P2 in terms of manometer. So this is equation number 2. So what do we do right now is, because we have equation number 1 and equation number 2 here, so what do? We do it this way. So equation number 1 should be equal to equation number 2, because P1 and P2, minus P2 is equal to P1 minus P2. So what we have over here is the same P1 minus P2, but with two different parameters. So what do? So we put this on the left side, 1, or Z2 over Z1 over here. Just now we have A as the representative. Okay, so Z2 minus Z1 is equal to A, so we use that as A. So on the left side we have A plus V2 square minus V1 square over 2G times rho G is equal to GH minus rho W plus rho HG plus OWGA. So if you put in number here, rho over here is water, so 1000 times 9.81, and here we have A as A. We don't know the answer yet, but we have plus V square over here. V2 square is 6.79 square minus V1 1.7 square divided by 2 multiplied by 9.81. So that will be on the left side. On the right side, G is 9.81, H is unknown, raw water is negative 1000 plus 13,600, and then plus raw water 1000 times 9.81 times A. Okay, so we will do some calculation here. So we will have here, okay, I need to divide this. Oh, sorry. So we have here 9810A plus, we get this number as 21,607.05 equals to, here we have negative 9810 and then H here, okay, and then we add 9810 times 13,600, sorry, 9.81 times 133,416, and then we add 9810A here. Since we don't know what is A, but however we have A on the both side with the same amount, it means that this A will cancel out this A, so we can just cancel this out, okay, and then we end up with this equation here. Okay, so to get the answer for H, so let me put it down here, 21,607.05, and then we bring this to the left side, minus 133,416 equals to negative 9810H. So H should equal to 11.4 meter. So that will be the H for this study.